Hi guys, Mr. Mix here once again. Today I want to look at what we call the cubic sequence. We've done the linear sequence, we've done the quadratic sequence, and then today we want to look at the cubic sequence. We've done the exponential sequence also. We want to see how the cubic sequence works. Again, if you have problems with the exponential sequence, you have problems with the linear sequence, you have problems with the quadratic sequence, please visit our other videos to get in-depth understanding of the other sequences, because it forms a very large percentage of your IGCSE exam. Sometimes you have 8 marks, sometimes you have 9 marks, I've seen 12 marks, I've seen 13 marks, I've seen 16 marks sequence in a particular exam, okay? So let's get into it quickly. So the cubic sequence, okay? Again, please don't forget, you can always visit the other videos on the quadratic, you can visit the videos on the linear sequence to have a complete understanding of what these sequences are all about. Okay, so for today, we are looking at the cubic sequence. So for the linear sequence, we said your first difference must be the same. For the quadratic sequence, we said your second difference must be the same. And now for the cubic sequence, your third difference must be the same. What does that mean? Okay, so you have 1, 8, 27, 64, 125. Okay, so let's get the first difference. The first difference is 7. Let me use a different shade of marker. Let me use the black for that. This is 7. This is 7. This is 19. This is 37, and this is 61. Let's go to the second difference. This is 12. This is 18. This is 24, and then the third difference is 6 and 6. Okay, so this is the first difference, this is the second difference, and this is the third difference. So the moment the third difference is the same, that automatically means it's a cubic sequence, okay? And then the same pattern we used for doing the quadratic sequence is the same pattern we're going to use for the cubic sequence. We will not use any formula. We will use what we call the n cubed sequence, okay? So let's get into it immediately by looking at the exam-styled questions, okay? Okay, so let me start with this one right here. Okay, so first let's confirm what did the question ask us to find. It asks us to find the nth term of each sequence. Okay, so let's quickly confirm. Okay, no, you know what? Let's just do the two sequences in view. Let's do these two sequences in view, and then let's make it as lively as possible. Okay, so let's see this. So this one, the difference is -2, the difference is -2, the difference is -2, the difference is -2. So that makes this a linear sequence. Okay, so what we do for a linear sequence is that we take the difference, that's -2, and just write an n in front of it. Put an n in front of it. And then ask yourself, if you're going to have a number before -1, what will that number be? Well, the number is 1. Okay, because if you put 1 here and then you do 1 minus 2, that gives you -1. Okay, so the n term of this sequence is -2n plus 1, and somebody can say 1 minus 2n. This is the same, exactly the same thing. Okay, so let's go to the second one, which is what we're dealing with. Okay, so let's confirm this is a cubic sequence. This minus this gives you 7. This minus this gives you 18. No, this gives you 19. This gives you 65 minus 28 gives you 37, and then this minus this gives you 61, and then the second difference gives you 12. This gives you 18. This gives you 24, and then the third difference gives you 6 and 6. Okay, so that makes it a cubic sequence. So now that we know it's a cubic sequence, what do we do? Okay, so what you do is you write what we call the n cubed sequence. For a quadratic, we said you write the n squared sequence. For a cubic, we said you write the n cubed sequence. What's the n cubed sequence? That's just 1 raised to power 3, 2 raised to power 3, 3 raised to power 3, 4 raised to power 3, and on like that. So 1 raised to power 3 is 1, 2 raised to power 3 is 8, 3 raised to power 3 is 27, 4 raised to power 3 is 64, and then 5 raised to power 3 is 125. Okay, so we said after writing the n cubed sequence, what you do is you compare the n cubed sequence and the key sequence you're given. Okay, so if you look at both of them, you'll discover that it's just a difference of +1, +1, +1, +1. Again, you go from the n cubed sequence to the sequence you're given, not from the sequence you're given to the n cubed sequence. That's why the n cubed sequence is written on top. Okay, so what's the nth term of this sequence? The nth term of this sequence is basically n cubed plus 1. because you added 1 to the n cube sequence to get the sequence you are looking for. It's as simple as that. Okay, so that's the first example done and dusted. Let's go to another example. Okay, of all this, you know what? Let's just do the 3 of them. Let's do the 3 of them at once. Let's do the 3 of them for clarity. Okay, so this is 5. This is also 5, and this is 5. That makes it linear. So the fifth term is 24. Okay, and then like we said, what we do is look for the difference. The difference is +5. So write your 5. Put an n in front of your 5. Okay, and then since it's linear, you wonder what number will be before 4. The number that will be before 4 is -1. Okay, so the n term of this sequence is 5n minus 1. Okay, let's go to the second one. You have 3. This is 7. This is 19. And this is 66 minus 29 should be 37. Okay. So what will be the next term of this sequence? Is a cubic sequence. It's a cubic sequence because I'm looking at it and I'm seeing that there's a relationship somewhere here, and the relationship is just, if I put my n cube sequence on top, that gives me 1. This gives me 8. This gives me 27, and this gives me 64. So clearly you will see that there's a difference of +2. After the linear sequence, the quadratic sequence is very, very easy to spot. Very, very, very easy to spot. So as you can see, this is +2, +2, +2, okay? So that means that if I write for the next one, which is 125, that means I'll just have 127 here. And what is our nth term? Our nth term is just n cubed +2 because the difference is 2. Again, you will notice that it is very, very easy to spot a cubic sequence. Okay, so let's go to the third one, sequence. See again, I have another video on the linear sequence. I have another video on the quadratic sequence. I have another video on the exponential sequence. Okay, so how do you know the sequence is exponential? You know it's exponential because you're multiplying everything by 4. So 1 times 4 gives you 4, 4 times 4 gives you 16, and 16 times 4 gives you 64. So what you do is, since you know you're multiplying by 4, you write every single thing in that sequence as a power of 4. So this 1 is 4 raised to the power 0, 4 is 4 raised to the power 1, 16 is 4 raised to the power 2, 64 is 4 raised to the power of 3. That means the next one will be 4 raised to the power of 4, which is 256. So how do we get the nth term? We said, since 4 is common to all of them, just write 4. And then just consider the powers. The powers are 0, 1, 2, 3, 4. So we said you find the nth term of those powers. And obviously the powers are usually linear sequences, okay? So the difference here is 1. So that means I'll have n, because 1n is n. And then if there's a number before 0, what's that number? That number is -1, okay? So that's n minus 1. So the power, the nth term of the powers is n minus 1, okay? So just put n minus 1 as the power, and that makes the nth term of the sequence. Again, don't forget, you can always hit the pause button. Look at the video very well before you hit the play button again for proper understanding, okay? So let's go to the next one, okay? So let's look at this one right here. You have 8, you have 15, you have 34, you have 71, you have 132. So let's look at the difference. This is 7, this is 19, this is 37, and this is 61. And then the second difference is 12, this is 18, and this is 24, and that's 6 and 6 again. Okay, so again, we write the n cube sequence on top of it, not below it. It's very, very important, on top of it. So this is 1, this is 8, this is 27, this is 64, and this is 125. Again, the differences are uniform, 7, 7, 7. So the n term of the sequence is n cubed plus 7. Again, I must say, the cubic sequence is the easiest sequence to spot after the linear sequence. Very, very easy to plot. Okay. So let's go to the one below. This is not part of it, but you can as well look at it. So when you have a fraction, so what you do is you find the n term of the sequence up, and then find this n term of the sequence down, and then you compare your answer. Okay, so please hit the pause button. Try and do it on your own, and then you hit the play button later, and then see if your answer and mine are the same thing. Okay, so if I consider the numerator, the sequence is 2, 3, 4, 5, 6. So clearly this is a linear sequence. The difference is 1. to write our n, and then if there's a number before 2, what's that number? That number is 1. So the nth term for the numerator is n plus 1. Okay? And then the denominator, we literally just did something like this. It is 4 raised to the power of n minus 1. So the nth term of this sequence is n plus 1 over 4 raised to the power n minus 1. The denominator is an exponential because we are multiplying by 4. That's literally what we just did in the question before this. Last question on this, on our cubic sequence, that sequence B, you have 0, you have 7, you have 26, you have 63. Again, cubic sequence is very, very easy to spot because this is, if I write the n cube sequence, this is 1, this is 8, this is 27, and this is 64. So what do? All you just do is just to do your n cubed minus 1, because the difference is obviously minus 1. So the nth term of this sequence is n cubed minus 1. That's the nth term of this sequence. And obviously you can use that to find the fixed term also. Okay, so that's how you find the nth term of a cubic sequence. Okay, thank you for watching this video. Please share, please like, please comment. Thank you very much for watching this video. Watch out for our next video. Thank you very much. See you next time. Bye.